Hello, everyone. We are back with another round of Turing Mock Interview series. I'm Jose, tech leader at Turing, and I am in Montreal, Canada. At Turing, I work on hiring the best engineer by helping them with the vetting process. And I have more than 17 years of experience, and my expertise lies in JavaScript. Today, I'll be interviewing Yopa for the role of an experienced Python developer. And let's see how it goes, okay? Let's hear from you, Yopa. So, could you please tell me a little bit more about yourself and about your background, and then I will take from there.
Hi, Jose. Thanks for having me. Hi, everyone. I'm Ngadu Yopa, a software engineer based in Cameroon with 3 years experience in Python and JavaScript. I've worked in several positions in the startup, mainly startup environments using Python, and I'm passionate about technology, innovation, and anything, tech related. Thanks for having me.
Cool. I see you have been worked so hard to get here, right? To get where you are. So could you please tell me a little bit about some interesting Python projects that you have been working on?
Okay, so apart from standard APIs we develop generally in Django Flask, I've had the opportunity to work on a smart diet recommender system, for meal recommendation, and some other interesting stuff about still recommender system, but for travel, flight, and other touristic based application. So those are some interesting works I've done with Python over time.
Nice. All right. So, okay, let's get started with this interview. Okay, I will ask you a few questions about Python. Okay, and the next step will be a live code challenge, and then we are good to go. Sounds good? Okay. All right. So, okay, my first question for you is, in your understanding, okay, what's the difference between a Python module and a package?
So a module basically is a file composed of functions, variables, classes. Then a package is a collection of those stored in a directory with a specificity that it has a double underscore init.py, which which sometimes have variables you want to be imported automatically. So that's basically the difference at the file level.
Nice. Okay. And so what's the proof of a single underscore variable in Python?
So the single underscore variable, so the way it's mostly used is as a standard for data that's to be ignored. Like when you want to catch exception, you can catch it as underscore, meaning you don't want to handle it. You can have it for I18N, that's internationalization. And when you are running Python in real evaluation mode, you can use it to get the previous statement that was that was wrong.
Cool. All right. So let's see. What is the difference? Okay, let's see. What's the difference between static and class methods?
So both are class level decorators. So the class method decorator, its specificity, it receives as first argument the instance of the class. It can access the class, it can modify it. Meanwhile, static variables are more like they are mostly used in the factory. When you have a factory method philosophy in software development, so it doesn't have an explicit. It doesn't receive the class explicitly, and they are generally used when you want maybe the class to perform some actions that does not necessitate it to be shared. That is not required that each instance of a class should have it as a separate method. So that's the difference according to me.
Nice. All right, and I realize you have a French accent. I suppose you speak French, right?
Oh, you realize that? I speak
right?
French.
Je n'ai pas parlé français yet, but let's move on. I'm learning. Okay, next time we'll have this interview in French. I promise you. All right. So, why are the full values shared between two objects or any objects?
So in my opinion, it depends. Actually, it's based on the way Python treats variables. So variables are generally treated as a reference to a particular thing. So when you create an object, you are actually creating a sort of you're actually instantiating instances of.
Okay, so I didn't quite get that. Could you repeat that, please?
Okay, so when you define a class, you are actually it's like you are already instantiating it somewhere. So it's stored in variable with the local variables. I mean, with the class variables being stored somewhere. So when you instantiate a member of that class and you don't provide a particular, let's say, local variable, and you try to access it, it looks in the class, it can't find it, it goes to a parent class or maybe an associated class. So that's how Python shares variables. So it's sort of weird. So way of sharing.
Got you. I got you. All right. So what is MRO in Python, and so how does it work?
So Python supports multiple inheritance. So in this case, when you inherit from a particular set, let's say 2 classes or more, and you are trying to access a method which can't be found directly in let's say in the daughter class, it searches the superclass. And in our case, where we have several parents, it searches from left to right. So that's the method resolution order in Python.
Okay, good. All right. So could you please describe, what do you understand about the Python's garbage collection mechanism? Okay, so have you ever heard about this? Can you brief?
Okay, so yeah, it's true. The language that brags about the garbage collection is Java, but Python also has its own way to collect them. It's a sort of automatic way, how would I say? So variables that are created first are checked to see if there's they're still holding a reference to a particular thing. Then there's this reference count. So each variable is supposed to reference something. So when it's no more referencing, or maybe what is referencing it has been removed. Oh, sorry. So when a memory location has no reference to it that was previously allocated, that part is being cleared off. That's what.
Nice. In what do you consider no reference? What should we do to help the garbage collection?
Okay, so we can have this function starts. So when a function is being called, everything is being stored in a particular, let's say, package, and when that context exits, it's being totally removed. So yeah, maybe that will
Gotcha. All right. Okay. What do you understand about the global interpreter lock and why it's an issue?
The global interpreter lock is a sort of mechanism that blocks multiple threads, so only one can be executed at a particular time. So yeah, that's the main role of the global interpreter lock.
Okay, gotcha. All right. Why use else in try except construct in Python?
Okay, so in Python, there's this possibility of adding an else block after a try statement. So what it does, it executes only if no exception was caught. So sometimes you might want to execute 2 blocks of code, which can each of them, the second block depends on the result of the first block. Let's say you need to read data from an API before you perform a particular check. So it's better to check if the API call runs well before you run maybe passing the data. So the except makes you, how would I say, make sure the first block executes instead of having two blocks that can each raise different exceptions, and at the end of the day you won't know exactly which one to catch. So that's what else permits something.
Nice, cool.
For the try catch.
Right. Okay, so my next question is why isn't all memory freed when Python exists?
So it has to do with this name spacing. So when the how would I say, the interpreter is releasing resources, all the resources might not be released at that particular time. So when Python exits, all the memory is not being cleared. So that's maybe a little issue the Python garbage collector has.
Thank you for answering my question today, Yopa. And the second part of this interview is the practical test, okay? But we're not going to be taking it today. So I want to give a heads up for our audience. So if you want to see the Python practical test, hit the like button, subscribe to our channel, okay? And comment down below. I want to see the Python practical test, and then we are going to make this video for you, okay? Other than that, follow Turing on Twitter, Instagram, Facebook, LinkedIn. Keep close to Turing because we are here to stay, and then I'm pretty much sure that we have a lot of tools, okay, a lot of resources to help you to increase your skills, okay? As that said, that's a wrap, and thank you everyone for watching.